Good morning, ma'am. Good morning to everyone. Myself, B.keerthi from CSM department. I'm here to give the presentation about the solve it optimally using domains principle problems. Here we go. Introduction to domains principle. The domains principle is the key concept in game theory. It allows for signification for decision making in competitive situations. This principle identifies strategies that are inferior to other can be eliminated. So understanding the payoff matrices. Payoff matrices represent the outcome of different strategies in a game. Each cell in the matrices shows the payoff for player based on their choices. Analyzing these matrices help in the determining the optimal strategies. Component of the payoff matrices. A payoff matrices typically consists of a rows and the columns indicating the players. Each intersection points represent the outcome for the player involved. Understanding these components is crucial for applying the domains principle. Types of domains. There are the two main types of domains, strict and weak. Strict domains occurs when the one strategy is better in all scenario. Weak domains happens when one strategy is at least as good in all the scenario. Identifying the dominated strategies. Dominated strategies are those that are inferior to other available options. Eliminating the dominated strategy, simplifying the analysis of the game. This step is essential in applying the domains principle efficiency. So steps to apply the dominance principle. The first step to identify all the possible strategies for each player. Next, compare the payoff across strategies to find dominated options. Finally, eliminated the domined strategies and simplifying the matrices. Example payoff matrices. Here is an example of simple payoff matrix. The row represent player A strategies and the column represent the player B strategies. Each will indicate the outcome of the both player based on their choices strategies. Simplifying the payoff matrix. After eliminating the dominated strategies, the matrix becomes the simpler. These simplifications makes it easier to identify the optimal strategies for the both players. A reduced matrix focus on the both most competitive options available. Finding the optimal strategies. With a simplified matrix, access the remaining strategies. Optimal strategies are those that provided the most possible outcomes. Determine the Nash equilibrium where both players has no incentive to derivate. Real world applications. The domain principle applies to various fields, including the economics and the politics. Businesses use the principle for the competitive strategies formulation. Political candidates may apply it to strategies that their company approaches. So here is the problem to solve the optimal using the domains principle. We need to analyze the payoff matrix and determine the whether any row or a column can be eliminated because it is dominated by another. So first step is to write the payoff matrices for the player A. The given matrix is player A, player B. It is the matrix. And the second step we have to eliminate the dominated rows. A row is dominated if all its payoff are less than or equal to payoff of other rows of the columns. Let's compare the rows to identify the dominance. So we have to compare all the rows and all the columns. So again we can eliminate the dominated rows. So compare the row 1 and the row 2. So column 1 4 versus 7, row 2 is better. So second column 6 versus 8, row 2 is better. And for the third column, so it 5 versus 5 is equal. So column 4 10 versus 9, so row 1 is better. So column 5 is 6 versus 10. So row 2 is better. So row 2 dominates as the row 1 in the 3 out of 5 columns. So we can eliminate the row 1. So we have to eliminate row 1 because of it has the more uh, better choices. So compared to row 2 and the row 3, column 1. So 7 versus 8 will row 3 is better compared to another. So column 2 8 versus 9, row 3 is better. Column 3 5 versus 11, so row 3 is better. So column 4, so 9 versus 10, row 3 is better. So column 5 10 versus 9, row 2 is better. So we have to think that so 7 is less than 8, so 8 is less than 9, 5 is less than 11. So we have to think like that and we have to give the better option for these. And so row 3 is dominated row 2 in 4 out of 5 columns. So we can eliminate the row 2. So compared to row 3 and the row 4. So we have to compare all the rows and to eliminate it. So column 1 8 versus 6, row 3 is better. So column 2 9 versus 4, row 3 is better. Column 3 11 versus 10, row 3 is better. So column 4 10 versus 6, row 3 is better. So column 5 9 versus 4, row 3 is better. So row 3 is dominated the row 4 in all the columns. So we eliminated the row 4. So step 3 reduces the matrices after eliminating the dominated rows. So after we are eliminating the rows, then we have to write the remaining rows. The remaining rows are the row 3, the best choice. So here is the remaining matrix. So next, identify the optimal column for the player B. Now for player B perspective, they will choose the column with the minimizing the player A's payoff. Will record the payoffs in the row 3. So column 1 8, column 2 9, column 3 11, column 4 10, column 5 9. So player B will choose a column 1 because 8 is the smallest value among these all the columns. So conclusion for this question, player A should choose a row 3 with the payoffs of 8, 9, 11, 10, 9, and the player B should choose a column 1 to minimize as the payoff for the player A. Means to choose the smallest value among these all the columns. So conclusion for this, understanding the applying the dominance principle is a crucial in the strategy decision making. It is enabling the player to focus on the best possible strategies. Mastering the principle can lead to better outcomes in the competitive environments. So thank you for giving this opportunity, ma'am.